Hello guys, today we'll be looking at the January 2023 CXC Mathematics Multiple Choice Past Paper. And without further ado, we get right into it. Let's go to question. Of course, you have your formula sheet. You can always make reference to this. If there's a formula that you're not able to remember, you can always come back here. Alright, starting off with question 1. It says, what is the value of the digit 2 in the number 48.627. Now remember the positions here. After the decimal point, you have the 10th position, you have the 100th position, and you have the 1000th position. Right? Which means when we say 100th, 2 is in the 100th position. It's really saying 2 over 100, which makes it option A. If it was number 6, it would be 6 over 10. If it was 1 in the 1000th position, it would be 1 over 1000. Moving on to question number 2. What percentage of 50 is 10? Now there's a whole lot of ways that we can go about doing this question. Right, remember that percentage means per 100. Alright, so I can say that 10 over 50 is equivalent to dash over 100. Alright, because why 100? Percentage is per 100, so it is with respect to 100. So the question is, what do I do to 50, or what do I multiply 50 by to get 100? I would multiply that by 2, and hence I would multiply the top by 2, so that becomes 2 times 10 is 20 over 100. And remember, we're looking at, basically it's just a matter of looking at equivalent fractions. So whatever we multiply the numerator by, we also have to multiply the denominator by as well. Some persons may not be able to use that approach. It's a pretty easy way to do it. You can also do it the traditional way, which where persons say, all right, it's gonna be 10 over 50 multiplied by 100 per 100, and we can put that over 1. You can go ahead here and do your reductions depending on how you do it. You know, we can take the zeros out. It's the same thing as dividing by 10. So if I take a 0 out at the top, 1 out at the bottom, it's like I'm dividing 10 by 10 and 50 by 10. Then here we have 5 down here, so we can say 5 into 5 goes 1. 5 into 100, you can break it down. 5 into 1 I can't. 5 into 10 is 2. 5 into 0 goes 0 times, so that is equal to 20%. Whichever way you take, it can work. Alright, we're going to be moving on to question number 3. Alright, and then it says, in standard notation, 0.02086 is written as. Now, in standard notation, the number in front of the point must be a number from 1 to 9. Alright, so it must be a counted number from 1 to 9. So automatically, there are some things we can rule out here. D is completely out. Alright, you have a 0 there, that's out. B is completely out as well. Now, do I need to go ahead and put this in standard notation? No, I can just go ahead and pick an answer. Now, could it, so it means it's between option A and C. Now, why can it not be option A? Because option A, whenever I expand this, I am supposed to get the original number. Looking at option A, it says I'm multiplying 2.0806 by 10 squared, which is really 100. 10 times 10. What persons like to do as shortcut is to count the amount of zeros, or just look at the power and move the point that amount of places. So we'll be going 2 places to the right to get the original number, which will be 208.06, which would be incorrect because guess what? My number is supposed to be 0.02. So that is completely wrong. In option C, we have 2.0806 times 10 to the minus 2. Now, whenever the power is negative, we know it's the same thing as saying that we're dividing by 10 squared, or we're dividing by 100. So when I multiply by with an index to a negative power, it's the same thing as saying division, and I'm going to show you what that means. Which does make sense, because 0.02086 is smaller than 2.0806. So I would have to divide in order to get the original number. So I know automatically that the correct option is option C. And let's make sense of this for persons who probably don't understand how the laws of indices work here. So this would be saying 2.0806 times 10 to the minus 2. In laws of indices, this is the same way as writing 2.0806 times 1 over 10 squared. Alright, so whenever you bring this up, the power becomes negative. Alright, what does this mean? It's the same thing as saying 2.0806 divided by 10 squared. And we know that 10 squared is really what? 100. And when we divide by 100, the shortcut is just moving the point to the left. So I'll be moving 2 places to the left. 1, add a 0 there, 2. Alright, so I know that this is the correct answer, option C. Now in question 4, it says that in a school, the ratio of the number of pupils to the number of teachers is 20 to 1. What does that mean? It means that for every 20 students, you have 1 teacher. If the number of pupils in the class is 840, how many teachers are there? So, if for every 20 students, I have 1 teacher. Now I have 840 students. How many teachers do I have? Pretty straightforward approach here. We just need to find out how many 20s we have in 840. So we can go 840 divided by 20. You can always apply your shortcut here, dividing by 10. So it's like we take out the zeros. 2 into 2 goes 1. 2 into 8 goes 4. And 2 into 4 goes 2. So that becomes 42. Alright, so for 840 students, we would need 42 teachers based on the ratio here of for every 20 students, we have 1 teacher. And of course, you can always rule out certain answers here like C and D, completely ridiculous. You know, those are out. Alright, in question number 5, it says a bag of apples can be shared equally among 6, 10, 50 or 15 children. The minimum number of apples that is likely to be in the bag is. Alright, let me give you the easiest interpretation of this. What it's basically saying, because if we're going to be sharing equally, there should be no remainders. So we want a number, or we want the lowest number that 6, 10, and 15 can go into. This is really just tapping into your multiples. So if we were going to do it the long way, talking about the multiples of 6, we're going to have what? 6, going up by 6, 12, 18, 24, 30, 36. You can keep going. Let's go in with 10, 10, 15. Sorry, am I saying 10, 15? We're going up by 10. So we're going to have 10, 20, 30, 40. You can keep going. If we go into 15, we're going to have 15, 30, 45. Now, I don't even need to go any further, because clearly we can see that the lowest number that all these can go into is 30. Right there. So we know the answer here is 30. Of course, all of these can go into 60 and 90 as well, but it says the minimum, which is a keyword here, as you can see in full capital letters. All right, we're moving over to question number 6. Now it says that if 4.3 times 0.37 is equal to 1.591, then 43 times 0.37 is. Now, let us write this back here. 4.3 times 0.37 is equal to 1.591. Now what they're testing here is your ability to use what we call the associative law. Right now, if you look at if you compare both expressions, you would notice the only thing that changed is the 43. So the 4.3 actually became 43. Now you're gonna ask yourself, how does 4.3 becomes 43? we would have to multiply it by 10. Right? So all I really did is to say we take 10, we multiply the left hand side by 10, 4.3 times 0.37. And remember, with the associative law, we can group any pairs, right? So 10 times 4.3 is really 43. That's how they get the 43 here. And notice the 0.37 remains the same. Now in simple math, we know that if we multiply one side by 10, we're also going to have to multiply the other side by 10. So it's the same thing as saying 10 times 1.591. And we know the shortcut for multiplying by 10, right? So you multiply a number by 10 is almost as if you move the point. The point technically doesn't move, but the shortcut way we do it, we say we move the point one place to the right, right? Which is going to give me what? 15.91, making that option B. All right, so all this is not even, we don't even need to go through this entire process. We look at the left, we said how is this different from this? We have 4.3 here, we have 43 here. How do we go from 4.3 to 43? Multiply by 10. So if I multiply the left hand side by 10, I must also multiply the right hand side by 10. And that's how we get the answer. All right, moving on to question 7. We have to know how to interpret these things. So it says, which of the following sets is best defined by the set of integers? Remember, we're talking about negative, positive numbers there, and 0. All right, now, and of course, we're talking about counting numbers. Let's clarify that part. That part is critical. So the set of positive and negative counting numbers and 0. All right, so we read this from the middle. X is a member of the set of integers such that x, starting from the middle here, is greater than or equal to -2, but is less than or equal to 4. Which means that less than or equal means that 4 can be included as well if it qualifies. Now, would 4 be an integer? Yes. Would -2 be an integer? Yes. So I want all of those from -2 to 4. So we're going to go -2, then what? -1 and 0, going all the way up to 4. And without even further ado, we can see that the correct option is D. All right. So we need to ensure we know our integer is critical there. All right, item 8 refers to the following Venn diagram, which shows two intersecting sets, P and Q. In the Venn diagram, the number of elements in P is equal to 5. The number of elements in Q is equal to 9. The number of elements in P union Q is equal to 10. Now let's understand what the union means. The union means everything that is in P and Q combined, the total in P and Q. With the intersection, this is what is unique. When you count P, you count the intersection. When you count Q, you count the intersection, which means that you will be counting the intersection twice. Now, how do I know what is in the intersection? I would take how much is in P. Number of elements in P is 5. Number of elements in Q is 9. So 5 plus 9. Somewhere in there, there's an amount getting counted twice. Now 9 plus 5 is 14. What is going to clarify everything for me is the number in P union Q, which means PRQ when you combine these two. So PRQ is all of this, right? So whatever is getting counted twice is inside of the intersection. Now we have 10. So both sets PRQ give me 10. All right. Now notice when I add the number of elements in P to the amount of elements in Q, I get 14. Which means that 14 is 4 more than 10. So I'm counting those 4 elements twice. So the number of elements in the shaded region, which let me take out what I have here. The shaded region is the intersection. Is going to be 4. Which makes sense. When I count P, I count the intersection. If I count Q, I count the intersection. It's counted twice. Alright, so let's take it to the next page. Going for question number 9. It says, which of the following pairs of sets is an example of a disjoint set? Now, let me just give you a graphical representation of a disjoint set. So you have set P, you have set Q. Means there's no connection between there's nothing overlapping. They have nothing in common. Now let's look at the first example. the set of even numbers, E equal the set of even numbers, and F equal the set of odd numbers. Does even numbers and odd numbers overlap at any point? No. I don't need to go any further. I know that my answer right away is option A, as in apple. Disjoint. There's no connection between them. If you go down to B, multiples of 2, multiples of 3. So if I go 2, 4, 6, 8, with 3, I go 3, 6. Right away, realize that 6 is common there. Alright? So, good question for us. Once we get the answer, we don't need to look at anything else. Alright, question number 10. All students in a class play Scrabble or checkers or both. If 36% of the students play Scrabble and only 16% of the students play both Scrabble and checkers, what percentage of the students play checkers but not Scrabble? Alright. To make it easier for you to understand, it's always good to have graphical representation. Alright, so here we go. Now, let's say we call Scrabble S. Let's say we call checkers C. 36% of the students play Scrabble only. Alright, so this 36% comes in here. They play Scrabble only. Put in the percentage there. The intersection is not involved. Now, 16% of the students play both Scrabble and checkers. So you have 16% here. Good. Now, we want to know what percentage play checkers but not Scrabble, which is really saying checkers only, because this will be the section in here, checkers but not Scrabble, which is checkers only. Now remember that all the students in the class, so there's nothing going to be on the outside here. They're not going to be students who does neither of them, because it says all students in the class play one or the other. Now we know that percentage is per 100, which means that all of these numbers need to add up to 100. So if I go 36 and 16, 6 plus 6 is 12, we put a 2, carry the 1, 3, 4, 5, 52. So we have 52% covered already, which means that we need to know how much more that makes it up to 100. So we just simply subtract the 52 from 100. Alright, we go 100 minus 52. And pretty easy there. One way you can do it is 50 from 100. It gives you 50. And take away the additional 2, gives you the 48 here, as in option B, as in banana. Alright, question number 11. Also a Venn diagram question. Alright, it says item 11 refers to the following Venn diagram, which shows two intersecting sets. The number of students in each set is indicated. So we have H, we have the intersection, we have V, which is 4 for volleyball only, 5 for hockey only. Hockey and volleyball, and we have 3 outside that play neither of these two. Now it says how many students play either hockey or volleyball but not both. So the intersection is out. We block this out. Either hockey or volleyball but not both. So we have 5 playing hockey only. We have 5 playing volleyball only. That's what we're looking for. They either play this or this but not both. So that's 5 plus 4 is going to give me 9. Number 9. So this all comes down to how you read the question. If I say how many students play either hockey or volleyball, they can play hockey they can play volleyball only, or they can play hockey and volleyball, which would be the 5 plus 2 plus 9. But if I'm saying hockey or volleyball but not both, intersection is completely not involved, right? Number 12. The set of 2-digit positive integers that are divisible by 7 is an example of. Alright. Is it an improper set? No. Is it an infinite set? Infinite means that it go on and on and on and on and on. Empty set? No. Because of course we can think of 2-digit positive integers that are divisible by 7. Being 14 being the first one. Then we can go what? After 14, the next 2 digit would be 21, and we can keep going. Now of course when we get to 100, after 100 we are out of 2 digits, we're going into the 3-digit realm. So is it infinite? No. Is it empty? No. We have some examples here. Is it a finite set? Yes. At some point we're going to stop, because we're talking about only 2-digit positive integers that are divisible by 7. If I had just set the set of integers divisible by 7, that would go on to infinity. But they're literally giving you a stop point. We're stopping at the 2 digits. All right, question number 13. For every $100 sale or part thereof, a salesman is paid $10 as commission. So when it says our part thereof, it means that also the fractionals will also count, right? All right, if his sales for a particular month were $1,020, how much commission would he receive? All right, we know that for every 100, he's paid a commission of $10. So all I need to find out is how many $100 can I get out of 1,020. So we can take our normal step, 1,020 divided by 100. And we know once we're dividing by a multiple of 10, it makes our life easy. As persons normally say, I'll just say the same thing. The point doesn't move, but persons will say, all right, we cross a 0, move the point 1 place. We cross an x0, move the point 1 place. All right, so that's 10.2. And in money terms, it's $10.20, right? Which makes sense. Now, for every 100, we're paid $10. Now we have 10.20 hundreds, which means we're going to be paid this amount times 10. We just simply multiply this by 10, which is going to be what? Same concept. All right, so when we multiply, one place to the right, so we have 102. Now, while the point doesn't move, we say that this is a shortcut, because when doing multiple choice, it's just matter that you get to the correct answer. All right, for the long paper, you need to know conceptually how this thing works, but we're just trying to get a correct answer here. So we don't have a point, we don't have a problem if it's easier for a person to say, all right, we move to the right, we move to the left. That's okay. Now, going on to question number 14. And it says the simple interest on 600 for T years at 5% per annum is 120. The value of T is. Now, if you go back to the second page on the sheet, moving on to question number 14. And it says the simple interest, and by just looking at the word simple interest, there's a formula. If we go to the second page, it shows the formula on the formula sheet. So we can start by writing that down. So simple interest is equal to my principal times my rate times time over 100. All right. Now it says the simple interest on 600 for T years at 5% per annum is 120. The value of T is. Now there's lots of things we can do. We can either go ahead and try to find what T is, or we can simply put in the information that we have first. So with the simple interest, we're told is 120. We're told that the principal is 600. We're told that the rate is 5%. We don't know time, which is what we want, over 100. Now, how do I get time by itself? That's a key. I need to get rid of everything here. Now, what do I get rid of first? I get rid of what is the problem first. So all of this is being divided by 100, which means I'm going to have to do the opposite, which is to multiply by both sides by 100. All right, now if we multiply by 100 on the right side here, it's just going to cancel out. So I don't even need to put it back there. I'm just going to have 600 times 5 times T. Now, if you look at this, you realize that both 600 and 5 are multiplying time. Now, persons like to move things one by one, which is to get rid of the 600 and get rid of the 5. But we don't need to do that, since they're both doing the exact same thing. Both of them are multiplying, which is the opposite, is to just divide by both of them. All right, 600 times 5. And we'll do the same thing over here, 600 times 5. All right, this gets taken out. Now we're looking for something that gives me that, which is 120 times 100, which we don't need to look further than option number B, as in boy. $2.60 is equivalent to US $1. For every US $1 exchange, 10 cents is deducted as exchange tax. How much US Eastern Caribbean dollars will Leon receive if he exchange 1,000 US dollars? Now let's establish a few things here. We can see that US is a stronger currency because it takes more Eastern Caribbean dollars to make one US dollar. All right. And whenever you're moving from the larger currency to the smaller currency, you're going to have to multiply. Now, we know that for every dollar that you convert, you're going to be removing 10 cents in terms of US. No, so there's so many ways that we can do this. It says Eastern Caribbean 10 cents is deducted as an exchange tax. All right, we have no problems with that. So let's go ahead and do our conversion. All right, so we have 2.6 times 1,000 because we're converting 1,000 US, right? Once again, you can move your points, but 2 times 1,000 is really 2,000. So we're going to have 2,600. This is in Eastern Caribbean dollars now, EC dollars. All right, now it says for every US $1 that is exchanged, Eastern Caribbean 10 cents is deducted. All right, so we are converting 1,000 US, and for every $1 of this, we're gonna take 10 cents Eastern Caribbean. So we just need to multiply this 1,000 by the 10, right? So we have 0.10 by 10 cents. Let me not say by 10, by 10 cents, which is 0.10 times 1,000. Now this is gonna give me 100. And once again, you can go ahead and move your point. All right, so we have 1, 2, 3 places moved, if that's the way that you do understand it. So we're gonna have $100 there for taxes, and this is in Eastern Caribbean as well. So we did our conversion, we got 2,600. If there were no taxes, you'd have gotten 2,600 Eastern Caribbean, but we're taking out $100 for taxes. So we have 26 minus 100, which is going to give us 2,500. So 15 is C as in Charlie. All right, moving on to question number 16. It says a calculator which is marked at 120 is sold for cash at 30% discount. How much change would Susan receive if she pays for the calculator with a $100 bill? All right, so we're going to be giving a discount of 30%. So there's a lot of ways that we can do this. If we're taking 30% off, we can go ahead and we can find 70% of the remaining amount. Remember, percentage is per 100, so we can go 70 over 100 times 120. 70% is what they will be paying, right? So we take this out, we take this out, this takes this out. Now we go 7 times 12. Now if you don't know the answer of 7 times 12, which you're really supposed to know, you're supposed to know that from your timetable. You can go 7 times 2 is 14, put a 4, carry the 1. 7 times 1 is 7, plus 1, 84. So $84 is what you'll be paying for the calculator. And you have a $100 bill. All right, so it's like you're saying, all right, I give you 100, you take 84 from it, you're gonna give me back 16. C as in A as in apple, right? 16A. Now some persons might not prefer this approach. You also have the option of saying, all right, do I go 30%? Find out what you can find what the discount is, which is the longer route. The way the easier way to do it with the 70% is say, all right, the whole calculator is valid 100%. You discount it 30%, so the calculator is now worth 70%. So that is why we took this approach to get the value of the calculator. You can also find the discount, 30 over 100 multiplied by 120. All right, you know how to divide by 10, and you should know, well, at least we should know 3 times 12 is 36, right? So this is my discount. So now if the mark price is 120, I am going to have to take 120, subtract the discount of 36. All right, and you know the steps here. Borrow 1, 10 minus 6 is 4, and then we go 11 minus 3, which is 8. So we get the price to be 84, which we take from 100 as well. So that's our next approach, right? We always want to do the quickest approach or the shortest approach. whichever is more comfortable to you. It doesn't matter. Question number 17. A man pays 60 cents for every 200 cubic meters of gas use plus a fixed charge. If he pays $178.75 when he uses 55,000 cubic meters of gas, how much is the fixed charge? All right. Now, what I need to find out is how much 200 is inside of this, the 55,000, because we know that there's a 60 cent charge for every 200, right? So I can go 55,000. Again, once, what are you seeing again? We're seeing how important it is to do manipulations which involves the zeros. At 550,000. All right, so we have 55,000. We divide that by 200 here. All right, take that down, take that down. So 2 into 2 goes what? 1 time. 2 into, I mean, we should be able to do all of this right here, right? Why did I cross that as 0 there? I'll put back my 0 here. All right, we know that 2, even if we can't do this, we know that we can say 2 into 5 goes 2 times. Remainder as 1, so we carry the 1 there. 2 into 15 goes 7 times. I still have another remainder of 1. Carry it there. 2 into 10 goes 5 times. So we have 275. Right? That is the amount of 200 cubic meters that we can get from 55,000. And bear in mind now that we are paying 60 cents per 200. Right? And we have 275 of them. So we're going to have to go 275 multiplied by 60, which is just saying 0.60. Because remember, we're talking about cents here. And we know the procedure for this. 0 times everything is 0. 6 times 5 is 30. Put on the 0 and carry the 3. 6, 7 is 42. 43, 44, 45. Put on the 5 and carry the 4. 6 times 2 is 12, and we're going to go 12 plus 4, which we know is going to give us 16. All right, makes sense? Now, of course, we have 2 decimal places here, 1, 2, so we put the point there. So we have $165. All right, so this is what we are paying for the 55,000 cubic meter of gas. But we also know that there's a fixed charge. Right? So what do? I need to take this from the 178.75 to know what my fixed charge is. So I just simply go 178.75, take away 165. You know, we can put some zeros there. We get our 75 there. Do I need to do anything else? No, I absolutely don't need to do anything else there, because this A is the only answer that has 0.75 at the end. So those are some shortcuts that we can use from time to time. All right, going down to question number 18. It says that a plot of land presently valued at 12,000 appreciates in value at a rate of 2.5% per annum. What is the value of a plot of land over 1 year later? So if it's appreciating, it's going up. So it's going to be more expensive than 12,000. Now the issue is with the answers here is that there is only one answer that is over 12,000, and that is answer D as in dog. So they're not expecting you to work out anything here. They're just expecting you to understand what the word appreciate means. If it was depreciate, we expect it to be less. And in real life, we know that land price is always going up. So you're not going to be expecting this to be less, unless it's some residence where something really went wrong and then land has gone down. But generally, land price goes up, right? All right, number 19. It says that a loan of 8,000 was paid back in 2 years in monthly payments of 400. The interest rate on the loan as a percentage was. All right. So if I'm paying monthly, now we're talking about 2 years. We know that 1 year is 12 months. 2 years must be what? 24 months. All right. the monthly payment of 400. So we can find out how much we paid back in total by just multiplying 400 by 24. So I'm going to say times 400. Now there are so many ways you can do this. We can just multiply 24 by 4 and add the 2 zeros at the end. Alright, I mean, because that's what you really do, right? Because when you say 0 times everything is 0, 0 times everything is 0. All you're doing is really adding the 2 zeros at the end. 4 times 4 is 16, so we put on the 6, carry the 1. 4 2 is 8, and 1 9. So we have 9,600, right? Now remember the loan was what? 8,000. So I'm going to have to subtract 8,000 to see what my interest is. Alright. I mean, this is going to be 1,600, right? So I'm paying 1,600 in interest. So it's 1,600 over 8,000. Of course, we're talking about percentage per 100, so we multiply this by 100. Now, do I actually have to do this entire working out? No. Notice that 16 is close to what? 1,600 is almost 2,000. 2,000 would have been a quarter of 8,000, which we should know is that a quarter is 25%. We have to be able to make these connections, right? 16 is a little bit less. So in my mind, I should be automatically be thinking 20. Well, let's say we're not thinking that. Let's break these things down. That takes that out. This takes this out. We now have 16 over 80. All right, if I want to, so we can take a 0 out here. We can take this out here. Right, we can say what? 8 into 8 goes 1 time. 8 into 16 goes 2 times. 2 times 10 is 20. But I didn't actually have to work this out. We can just look at the numbers relatively, right? 16, 80, right? 5 times 16 gives me 80. So I'm thinking 1/5. There are some common fractions that we need to know what the percentage is, right? Like 1/5, 20%, a quarter, 25%, 1/3, 33, third. We just need to know what these common fractions are. It makes it easier when it comes on to multiple choice, right? All right, question number 20. An article bought for 125 was sold for 175. The percentage profit the percentage as a profit of the cost price is. How much profit did I make? I sell for 175. I bought for 125. All right, so we just need to subtract to get the profit here. All right, 7 minus 2, that's 550. Yeah, 1 minus 1 is 0. Not so important there. So now we have 50 over 125. Good. Now, once again, as we say, you should be able to break these things down. Now, well, if you want to put times 100 there, which you don't have to do, we just need to know what this common fraction is. Well, one thing we are sure is that when numbers end with 0 and 5, 5 can go into them. But right away, we should also know that 25, which is a quarter of 100, can go into both of these. So if you're not sure, you can start with your 5 and break it down. Takes a little bit longer, but it does work. But just by looking at these numbers, we should know that 25 can go into 52 times. 25 can go into what? 125 5 times. Now this, we can even connect this question to the previous question. Notice we're getting 2/5 here. We already knew that 1/5 was 20% from up here. So 2 of those 2/5 is going to be double. So it must be what? 40%. But let's say we don't know that. We can go ahead and take this down. 5, we have a 5, we have 100 up here. We know that 5 can go into 100. 5 into 5 1 time. 5 into 10 goes 2. 5 into 0 goes 0. 2 times 20 is 40%. So there are so many different ways that you can do a multiple choice that makes it even much easier for you. Question number 21. The product of a number 2p over 3 and its reciprocal may be written as. Alright, so the product means we multiply, right? 2p over 3 multiplied reciprocate. It's just the same way as saying we flip it. Whenever you reciprocate something, you just flip it. Numerator becomes denominator. Denominator, which is 3, becomes numerator. All right, so we're looking at option C here, as in cat. Question number 22, and it says, refers to the following diagram below. The area of the rectangle in square centimeters is x squared. The equation that best represents the value of x is. Alright, so we know that area here is length by width. It's a rectangle, area equal length by width. It doesn't matter which one we call the length, it doesn't matter which one we call the width. Alright, now they told us that the area is x squared. So where you have a, you can put x squared there. Length, as we say, it doesn't matter, so we can go 2 by the width, has to be in a bracket because it's being represented by more than one term. So we have x minus 4. Now do we see that answer here? Yes, option A, as in apple. So we just need to put down the information as they give it to us, right? Althea normally saves x dollars each month, but in June she saves $4 more than twice her usual amount in June. So she normally saves x. All right, let's start it from step 1. In June, she saves 4 more. 4 more means that we have to add 4. All right, we're taking the step at a time. Then twice her usual amount. Her usual amount is x. All right. Now, if I'm gonna say she saves 4 more than twice her usual amount, then of course all we have to do is multiply the usual amount by 2. Twice means we multiply by 2, right? So we're gonna have 2 times x, which is 2 times our usual amount, plus 4, which is an x, we have just saying 2x plus 4. All right, so we just read the question as it states. Now, why could it not be C? Because C is insinuating that she is saving twice the usual amount plus 4. So twice all of that. But in the answer is saying that she saves 4 more than twice her normal amount, which was x. So you have to be careful how you interpret the questions. So here we have 23, D as in dog. All right, number 24 says that 3 plus x over 2 is equal to 1. The value of x is. Now we can work this out, but guess what? We have the answers on the page, so we can do trial and error, right? Now, let us, for example, ignore the negative signs. If we were to use 11 here, 11 divided by 2 is going to give us a decimal. And 3 plus some decimal is going to give you a decimal as an answer. So we know it can be negative 11. Let's try negative 4. So 3 plus negative 4 over 2. All right, negative 4 divided by 2 is negative 2. We know how this works. 3 plus minus. So I have 3, right? And I take 2. All right, I subtract 2. So we have plus minus 2. All right, plus take away 2. Which is just the same thing as saying 3 minus 2, which is going to give me 1, which is my answer. So I know negative 4 is what I'm looking for. Number 25. And this is really what we call the laws of indices. So we're multiplying two things that have the same base. So the simple shortcut here is that we keep the base. Once the bases are the same and we're multiplying, we keep the base, which is 5. We add the powers. So we have n plus 1 plus n plus 2. Now you're looking for like terms, right? N and n, 1n plus 1n, that's 2n. Number 1 plus number 2, that's 3. So we have 2n plus 3 as the power. Looking for that there. Alright, don't get tricked by the other things that you see. Alright. Number 26. Now a asterisk b is equal to a squared plus b squared. The value of 3 asterisk 4 asterisk 2. Bid mass, guys. We always do what is inside of the bracket first. Bid mass. So I'm focusing on 3 asterisk 4 only. Now comparing this to the A asterisk B, it means that 3 is A, 4 is B. So I'm going to have 3 squared plus 4 squared. Now I'm not going to work this out because they never worked it out. So we're going to have, so the answer is 3. So all this, the 3 asterisk becomes, the 3 asterisk 4 becomes 3 squared plus 4 squared. But that's not the final thing, because all of this now needs to asterisk 2. Now how do I not get confused? Everything in front of the asterisk is A. Everything after the asterisk is B. Okay, so they did actually work this one out. Alright, so we know that 3 squared is 9 and 4 squared is 16. So we add those two, simplifying. So we're going to have 9 plus 16, which is 25. So we're going to have 25 asterisk 2. Now notice I can take out the brackets now because I got an answer here. And this is no longer complex, right? The bracket normally make life easier for me. So now I have 25 asterisk 2. So my 25 is now my A. And my 2 is now my B. So I'm going to have 25 squared plus 2 squared. A as in apple. Alright, I probably never needed to work that out either, because I mean, once I got the 25, that's practically the question is over. Alright, now it says if the determinant of A is equal to 0, then now those two symbols around A means determinant, right? Is equal to 0, then A is what we call a singular matrix. So once I say singular, you know the determinant is equal to 0. And it could have been a case where you would have to work out an equation there. The important thing, determinant is 0. It's a singular matrix. All right. Question number 28. Now it says if A is equal to all of this here, then the order is just the amount of rows by columns. Now how do I differentiate rows and columns? Rows are horizontal, right? 1, 2, 3. Columns are vertical, so we have 1, 2, 3, and 4 columns. Now what comes first? Rows, then columns. So it's gonna be, we have 3 rows by how many columns? 4 columns. Probably I should use the same colors here so we don't get mixed up here. So my rows were red, 3. My columns were green, 4. So it's a 3 by 4 matrix. Alright, moving this down. 29. It says if vector P and Q are, so P is 3, 2, Q is minus 1, 4, then minus P minus 2Q. So we're just going to do minus, we're going to set up vector P, 3, 2, minus 2, and vector Q is negative 1, 4. Now this minus sign in front of this is going to change everything in there to a negative. So we have minus 3, we have minus 2. We can put the minus sign back there, and then we multiply this by 2. So we have 2 times negative 1, negative 2, 2 times 4 is 8. Now some persons might say, why didn't I just multiply everything by a minus 2 here? I could have done that, but then I'm going to have to put a plus sign in between to separate them. So here we're going to have negative 3 minus negative 2. We know how this works. Minus minus. So this negative times this negative becomes a positive. So it's really saying negative 3 plus 2, which is equal to negative 1. Now, do I need to work out the bottom part? No, because there's only one answer here that has a negative 1 as my top answer, and that's this one down here. But let's, for argument's sake, let me work out the bottom one. So you're also going to have, let me use a different color here, a negative 2, you owe 2, minus 8, you borrow 8 more, you're going to owe 10, so minus 10. All right. Question number 30, I believe, yes, refers to the following diagram of triangles OLM. So OLM. in which R is the midpoint halfway of OL here. So let's say we put on arrows here so we don't get confused. Now OR is equal to 3A minus 2B. So this is 3A minus 2B. That is just a midpoint here, which means that RL, if R is the midpoint, it means that RL is going to be the same thing. We can definitely agree on that. So let me get a put in there. Right? Because midpoint means halfway. So it means up here as well is also 3A minus 2B. Alright, and then we're also told that OM, alright, nice, is equal to 2A plus 3B. 2A plus 3B. Let me get a different color here. What do they want us to find? They want us to find LM. Perfect. So if I need to figure out how I'm going to get from L to M. That color is not so bright at all. Let's go blue. So if I'm going from L to M, I'm going to have to go the opposite way now. So you see what's the sign changes. Once you go the opposite way of the arrow, the sign is going to change. So I'm going to have to go from L to O, then from O to M. So you start at L, you end at M. Alright, so we have 3A. In this case, we have 3A minus 2B, which we can multiply by 2. And because it's two of them, right? Instead of adding it twice, we can just multiply it by 2. And because this is OL, and we're changing the direction, all of this is going to be negative. So in essence, we can just say negative 2 times 3A minus 2B. And you do understand why we're multiplying by 2, because it's two of them. We can add both of them, which is the same effect as multiplying by 2. The negative sign is because we're changing, we know what OL is, but we're taking the opposite direction. So you change that to a negative. Now, plus, look at OM now. We have the same direction, so we keep the sign. It's going to be positive. 2A plus 3B. Now we do brackets first. So we have negative 2 times 3A, negative 6A. Negative 2 times negative 2B. Negative times negative is give you a positive. So you have a positive 4B plus 2A plus 3B. Alright, look for your like terms. Negative 6A plus 2A. Negative 6 plus 2 is going to give me negative 4. And then 4 plus 4B plus 3B's gives you 7B. Both are positive, right? Now, do I see negative 4A plus 7B? No. But guess what? The commutative law tells me that I can also write this as 7B minus 4A. They're still the same thing. 7B is positive, comes back as a positive. 4A is negative, so it comes back as a negative. Which this looks like to me like option B, as in boy. Question number 31. It says the volume of the cylinder in cubic centimeters and in terms of pi is. Now, we know, or we are told that for any prism meaning that it has a uniform cross section, which means that if you cut this anywhere, you're going to get a circle. We just need to find the area of the cross section times the distance between the two faces or the two cross sections. Now up here it's a circle, and we know that once we see a circle, the area of a circle is pi r squared. Alright, and then the distance times this. Now when we multiply by the distance, that is where we get the volume. So volume becomes pi r squared times the distance between the two faces, which is 20, or we can call it the height. Now it says in terms of pi, so I'm never going to put 22 over 7 where I have pi. I need to leave the pi as it is. Here we are showing that the diameter is 6. Now what's the relationship between radius and diameter? The radius is half of the diameter, so it's going to be pi times r squared, which is going to be 3 squared times 20. Which 3 squared is 9 times 20. Don't forget the times pi. We're not replacing the pi with 22 over 7 because it said leave it in terms of pi. So we're going to have 9 times 2, which is 180 pi. So the volume in terms of pi is going to be 180. All right, 180 pi, which is what we have there. I mean, they never put the pi attached to it. Normally they would have attached the pi, but I guess you get what they're saying here. So it shall be in pi there, but you got the answer 180, so you know that C is the best answer there, right? Next question, number 32. All right, number 32 refers to the following diagram, which shows a circle, center O, and with a sector, the major and minor arcs indicated. Major is a longer one, of course, minor is a smaller one. If the area of the minor sector EOF is 103 square centimeters, then the area of the circle is. Now, what's the most important thing we should always know? There is a connection between the sector and the area of the circle. Because if we were to continue drawing this thing going all, remember, this is one revolution is equal to 360. This is just 60 degrees. So if I can take this out and fill out the entire 360, that means I'll get the entire area of the circle. So I could have gone in and put in some more sectors there to see how much more I need to fill out the circle. But I don't have to do that, because I know that the entire revolution is 360. So I just need to divide 360 by 60. Why? Just to find out how much of these sectors I need to fill an entire circle. If I can find out how much of them, then the area of this times that amount will give me the area of the entire circle. So we go zeros. You see how important it is to work with division involving 10 and multiplication. 6 into 6 is 1, 6 into 36 is 6. So it's going to take me 6 of these sectors to fill the circle. I know that one sector has an area of 103 square centimeters. So I take that times 6. 6 threes, 18. Put on the 8, carry the 1. 6 times, do I need to go further? No. There's only one of these that ends in an 8, and that's option D. But 6 times 0 is 0, 1. 6 times 1 is 6, right? Once you get part of the answer that is only unique to one answer, then you're done. Question number 33. If it took a speedboat 9 hours to travel a distance of 1,080 kilometers, what's the average speed in kilometers per hour? All right, what are they asking you? Basically, they're just asking you how much kilometers are you covering in 1 hour. That's basically all they're asking you. We're talking about a speed here. So you cover 1,080 kilometers in 9 hours. How about what are you doing per hour? So it's 1080. That's why they call it the average, right? Divided by 9. Now, here's how I would look at this question. I have 1080 divided by 9. Now, this might take me some time to divide this by 9. Could I make my life easier? What if I round the 9 up to 10? If I divide this by 10. If I divide this by 10, I would get 108, right? So 1080 divided by 10 would give me 108. So I know that my answer is going to be close to 108. But if I divide by a smaller number, 9 is smaller than 10, I'm supposed to be getting what? A larger number. So I know it can't be 102. D is completely out, so it must be C as in cat. If you guys see what I did there. Or you can take the step, of course, of doing your long division. You know, but there are always ways of finding shortcuts around this thing. You could always go 9 into 1080 and you work it out. You can do that. But learning the shortcuts is key, right? So 9 into 10 is 1. 9 times 9 is 9. 10 minus 9 is 1. You carry down the 8, right? 9 into 18 is 2. 9 times 2 is 18. 0, 9 into 0, 0. Right? So, but sometimes there are shortcuts. You just divide by a number that's much easier, that is closer by, and gives you an idea, right? All right, question number 34. The lengths of the sides of a triangle are. All right, now I always like to draw a diagram when it comes down to these things. So we're gonna put in x, 2x, 2x, which in some sense tells me that this, because if two sides are equal, we're thinking about what? An isosceles triangle. Alright, so it says if the perimeter is 20, what is the value of x? We know that perimeter is the distance around. When you add up everything going around, it's going to be equal to 20. So let's take the length of each face. So we have 2x, we have 2x again, and we have x. So if you have 2x's plus 2x's, that's 4x's, plus 1x, that's 5x, is equal to 20. I can simply say what times 5 give me 20? 4 times 5 give me 20. Or you just go 5x over 5, 20 over 5. 5 times 4 is 20. So that's option A as in apple. Question number 35. It says that, let me pull this over a bit. It says that 50 guests had 2 glasses of champagne each. Each glass has 150 milliliters. How many milliliters of champagne, or how many liters of champagne were used? Now, what does milli mean? Milli mean 1,000, right? So it takes 1,000 millimeter or milliliters to make 1 liter. So 1,000 of this make 1 of this. So let's find out what happened here. So each guest, you have 50 guests at the party, right? And each guest had 2 glasses. So 50 times 2 is equal to 100. So we had 100 glasses of champagne being used there. Now each glass has 50 milliliters, right? So we'd have to multiply 100 by 150. I said 50, but it's 150 milliliters, right? So that's gonna, and once again, the power of the 0. So we take these 2 zeros here, attach them here, we're gonna get what? 15,000. Alright, and so we're looking at 15,000 milliliter. But we want answers in terms of liters. So we know we're gonna have to divide that by what? 1,000. So we go 1, 2, 3. So it's gonna give me option C for 15. It's just a power of knowing how to manipulate division by, well, division or multiplication by 10 or powers of 10 thereof. If you know that, you can see how many questions you'd have easily gotten already, right? So ensure you master using division and multiplication by powers of 10. All right. It says a square has the same perimeter as a rectangle with lengths of 15 and width of 11 centimeters. So what is the area of the square? All right. All right, now we know that on a square, all the sides are equal. On a rectangle, opposite sides are equal, right? So let's start off with a rectangle that we know. So over here we can say, all right, this is 15. Well, let me not do it that way, because 15 is way more than 11. So let's say we have 15, 15, 11, 11. All right, so opposite sides are the same. With a square, we know all the sides has to be equal. So this entire distance are going around here. All of these lengths are the same. So I need to find out exactly what the perimeter of this rectangle is, which is going to give me 15 plus 15, 30. 11 plus 11 is what? 22. So we have 52. Make sense? This is the perimeter of my rectangle. My square has the same perimeter. All right, so we know that we have lengths here. We know that the length plus length plus length plus length is equal to 52. Now, of course, this is a complete waste of time because they're all the same length and it's 4 of them. So we can say 4 length is equal to 52. So I divide by 4 because I want to know what the length is. Huh? And if you don't know how much time 4 can go into 52, you can say 4 into 4 goes 1. 4 into 5 goes 1, remainder 1. 4 into 12 goes 3 times. So that's 13. So the length of any side of my square is 13. I want the area, which the area is equal to length times length, which is length squared. So we have 30 times 13, which is 169. Now, what if you don't know that 13 times 13 is 169? You can do this. 13 times 13. 3 is 9. You don't need to do anything else, right? Question number 37. Let me get some space over here. All right, what is this question 37 saying? It's saying that the circumference of a circle is 154 centimeters. Pi is 22 over 7. The radius of the circle in centimeters is. Start off with what you know, right? The circumference. Now, what's the formula for the circumference? And once again, this is also on the formula sheet at the top. 2 pi r. Now, we know the circumference. We can put that in. 154 is equal to 2 times pi. So we should use pi as 22 over 7 times r, which is my radius. My radius is what I don't know. That is what I need to find. All right. Now, what's the easiest approach to do this? I can do trial and error, of course, and see if I get the answer. That's one way to do it. So I could notice my first answer here is 7. What happens if I put 7 here? We would say 7 into 7 goes 1 time, so that's gone. 2 times 22. 2 2's 4, 2 2's 4, 44. Of course, that is some distance away from what I want to get. So, nah, we wouldn't be working with 7 there. Let's take a next nice rounded answer and try that. Let's say let's leave the decimal for now, which is b. Let's go 49. Let's say we put, this is 22 over 7, of course. All right, let's put 49 here. Now, 7 into 7, 1 times. 7 into 49 goes 7 times. 2 times 22, which we already know is 44. If we multiply that by 7, would that work? No. 4 times 7 is 28. 7 times 4 is 28 as well. So 7 times 4, 28, 29, 30, 308. Clearly this is ridiculous and this could never work, right? So we know that this is out. Which, are we going to use a bigger number? No, we're going to get a much higher number than 308. So it must be the one with the decimal, which is b. Now, I could have saved myself some time as well, like when I did the first trial and error, because bear in mind that we had 2 times pi, which is 22 over 7, times 7 when we tried 7, right? We got 44. Now, looking at 44, looking at 154, you might be thinking I must multiply by 3 or some small number that would bring me up to 54. And if you look at 7, 3 times 7 is 21. So 24.5 is kind of close to being 3 times 7. So in a sense, we could reason out that in order to get 154, the most likely answer would be this. You know? Because going all the way up to 49, that's going to be way too huge, of course, as you can see. But once again, that's a way of doing it. Trial and error, you can never fail doing that. Now, question number 38. The diagram, the distance around a lake is 8 kilometers. On a map, this distance around the lake is represented by a length of 2 centimeters. The scale on the map is. So what they're saying that, a map is small, so I'm gonna have to use a small distance to represent that 8 kilometers. If I'm actually using 8 kilometers, I would probably need a very huge size paper. And that wouldn't make any sense, right? Because you're only doing a representation. So I need to know what the scale is, right? If I'm taking that 8 kilometer all the way down to centimeters, what do I do? Well, we can take it step by step. We know that 1000 meter is equal to 1 kilometers. And we know that 100 centimeter is equal to 1 meter. So if I'm going all the way from kilometers, which is the larger unit, to centimeters, I'm gonna have to multiply by these two things, right? So it's gonna be 2 converting that 8 kilometers to centimeters. Once again, we multiply by 1000, we multiply by 100, the power of the zeros. We put the 8, we just add up. How many zeros do I have? 1 2 3 4 5. 1 2 3 4 5. Because that's all you do when you multiply by powers of 10. You just add the zeros to the end. Now we wanted to break it down as in ratio here, so we can divide both of these by 2. So we divide 2 by 2, we get 1. We divide 8 by 2, we get 4. We'll put back all the zeros there. 1 2 3. So that's 1 to 400,000. Option D as in dog. Question number 39. All right. Item 39 and 40 refers to the following table below, which shows the number of books that 58 students bought at a sale. The mode of the number of books bought is. Now, mode is the most frequently occurring. So which number did most students buy? So we're looking for the number of students, and we're looking for the highest value. So 13. All right. Now this is the frequency, or this is 13 students bought 5 books. So the modal number of books bought is 5. So 13 is not the mode. 13 just tells you which one is done the most, or how much time it is done. So 13 students bought 5 books. So you have to be careful in this case. So the mode is 5. All right. Now question number 40. The median number of books bought at the sale is. Median is the number in the middle, right? So have 58 students here. Once again, we're looking at the frequency. We want to find midway. So we could have written this out, all the numbers going down, but that would be a waste of time. How do I get to the middle? That's what I want to find. So when it comes down to median, we go n plus 1 over 2. All right, so it's going to be 58 plus 1, which is 59 over 2. Once again, we do the same thing. So we said 2 into 5, 2, carry the 1 there. 2 into 19 goes 9 times. Still have a decimal, we still have a remainder, which is 1. 2 into 1 is a half, 29.5. So we're gonna add until we get to 29.5. So we go 9 plus 9, that's 18. And if I go 18 plus 13, that's gonna way past 29.5. So when we get 29.5, we know that the median is the number between 29 and 30. Right? So we'll take the numbers in these two positions, add them and divide it by 2. That's basically what we're trying to do. But notice we got 9 plus 9 is 18. So we're going to be passing the 29th and the 38th number at 5. So 5 is in those two positions. So the answer becomes 5 as well. Alright, that's one way of looking at it. Question number 41 refers to the following pie chart, which shows the popular games played by a group of students. If 180 students play football, alright, so football is right here, 180. How many students are in the group? Now, one of the things about understanding circles is the ability to understand like how angles are represented. Now, whenever we see this box here, we know that this box, which is a rectangle, meaning that the corners are 90 degrees. So this is representing a 90-degree angle, right? So we know that the entire circle is 360. Right, so this is the easiest way to reason this question out. 90 degrees represents 180 students. The entire circle is 360. Represents x. The only question I need to ask myself is how many 90s are in 360. So if I do 360 over 90, once again the power of zeros, 9 into 36 goes 4. I know it's 4. So it's gonna be 180 times 4. Alright. So 4 times 0, 0. 4 times 8 would give me what? 32. Carry the 3. 4 times 1 gives you 4. If I add a 3, I get 7. 720, right? C as in cat. Question 42 refers to the following chart, in which shows the amount of fish bought in kilograms by the first 60 customers at a fish market. Alright. How many customers bought at least 6 kilograms of fish? Now, at least means 6 kilograms or more. Alright, so we have to understand what these terms mean. So it's going to be 6 or more. So it can be 6, 7, 8, 9, or 10. So let's start at 6. So at 6 we see we are between 10 and 12. So we have 11 customers there. At 7 kilograms we're between 4 and 6. So we have 5 there. At 8 kilograms we can see we're exactly at 4. 9 kilograms coming across. Halfway between 6 and 8, that's 7. And then finally, 10 kilograms are between 2 and 4, that's 3. So let's add up these numbers. So we go 11 plus 5, that's what, 16. Now we have 16 plus 4, that's 20. 20 plus 7, 27. 27 plus 3 is 30. So we have 30 customers bought at least 6, which means 6 or more, right? Next. We're almost there. Question number 43 refers to the following diagrams, which shows the cumulative frequency curve of the heights of 20 plants. The interquartile range of the measurement is, interquartile range, we're going to say it's Q3 minus Q1. Now, quartile means quarter, right? Q3, all we're thinking about is 3/4. Q1, thinking about a quarter. So I need to know what the 3/4 position is, which means 3/4 of the total frequency, which is 20. And we need to know what quarter position is, which is just we saying, all right, 4 into 4, 1. 4 into 20 is 5. 3 times 5 is 15. So we need to know what is in the 15th position. Quarter of 20 is 5. So this is what we have to do. So we're going to have to find 15, go across, and come down. Because we're looking at the height. Don't get tricked by these values. We're going to have to find 5, go across, and come down. All right, so let's make sure we're on the same page here. I need to get this line a little bit straighter so you can see exactly what's going on. So let's get the line straight here. So 15 right across here. Still a little bit messy. And then we come down on that line there. It should be exactly on the line. Alright, but you guys get what I'm saying right here. Getting this line straight at all. Alright, that's it. Perfect. Let's take out the additional things here. Alright, let me just go back to the freehand because I took that out. Alright, so 5. Whoa, I erased everything. Undo. Alright, so we were looking for the 15th and the 5 position. So it's better I use a freehand here because I'm not getting that line perfectly straight here. You see, goes to the middle. Come down in the middle there. And then I was at 15. 15 go across here. And then come right down on this line here. Alright, so I need to find the corresponding heights down here. Alright, now I need to know what I'm going up by. So if you notice here, if we go 2 point, we have 1, 2, 3, 4, 5. And we have 2 going up there. Alright, so if I divide 2 by 5, I get 4. So we're going up by 0.4. Now that makes sense because if we go 2.4, that's the first one there, 2.8, 3.2, 3.6, and so on. Alright, so in the middle, so let's start with the first one here, which is the 15th position. So we got 4.4, 4.8, 5.2, minus, if we go 2.4, remember you're gonna have 2.4 then 2.8, so it's gonna be in the between 2.4 and 2.8, 2.6. So it's going to be 5.2 minus 2.6. Which, I mean, if you want to do this like 5.2, 2.6, you know, you borrow 1, 4, 12 minus 6, it's going to be 6, 4 minus 2, so that's going to be 2.6 here. No, I think what would probably give persons most problem is to find out what you're actually going up by, right? I think that would have been the issue. So one of the easy ways we normally do it is that we see we're going from 2 to 4. We see how many lines are in between here. 1, 2, 3, 4, 5. So we're gonna have 2 divided by 5. So you see how important now it is to know your decimals. We know that 1/5 is 0.2, so 2/5 is 0.4. Alright, so we're going up by 0.4. So that is why it comes down. It's very important for you to know like common fractions. It makes your life easier. Alright, question number 44 refers to the following table, which shows the results of a survey of 100 persons from 2 major ethnic groups, P and R. Respondents were interviewed about their attitude towards mathematics. Alright, so let's see what they're saying here. So positive, so we're looking at the ethnic group, right? So P, positive, we have 25 persons positive about mathematics. R, we have 12 persons. Neutral, we have 11, 9. Negative, we have 24, and we have 19 there. Alright, let's see. A person a respondent from either group P, from ethnic group P is selected at random, what is the probability that he has a negative attitude towards mathematics? So we're focusing on group P now. Ignore the group R. Focusing on group P only. Alright? Which has a total of 60. So it's going to be out of 60. So we have a total of 60. We're looking for the persons that have a negative attitude towards mathematics. So looking at, well, alright guys, so move on to question number 44, which refers to the following table, which shows the result of a survey of 100 persons from two major ethnic groups, P and R. Respondents were interviewed about their attitude towards mathematics. So you can see here, this is what we call a contingency table, showing how many persons in group P are positive to maths, how many persons in group R are positive, neutral for either group, and negative for either group. So it says a person, or respondents from ethnic group P is selected at random. So we're selecting somebody from ethnic group P at random. What is the probability that they will have a negative attitudes towards mathematics? So what we're doing here is that we're focusing on group P, and we're focusing on group P only because it tells us a person is a respondent from ethnic group P is selected, so they're targeting ethnic group P specifically. What's the probability that their attitude towards mathematics would be negative? So we have 24 negative people towards mathematics in group P, and in group P we have 60. And then all we need to do is to break this down, right? So what can go into 24 and 60? Some persons might start with 2, some persons might know that they can start with 6. So if we go 6 into 24, that's going to be 4. 6 into, and we could also use 12. 6 into 60, that's 10. We can go 2 now. 2 into 4, that's 2. 2 into 10, that's 5. So we have 2/5. Now persons might be asking, why didn't we use 24 over 100? Because we are told that the correspondence is selected from group P. So we're just focusing on group P. All right, let's see. The point where a linear function crosses the horizontal axis, and we know what the horizontal axis is, there is the x-axis, so it must be the x-intercept, right? If it cuts the y-axis, it's the y-intercept, but we have to focus on what it cuts. Horizontal axis, x-axis, vertical axis, y-axis. All right, relationship. So item 46 refers to the following mapping diagram. The relationship that best describes the mapping in the diagram is, all right, so we're gonna look at what is happening. So we have this one going to this, we also have this one going to this, we have this going to this one, we also have this going to that one. So we have more than one thing going to one thing. So in other words, you have many going to one. So it's a many to one. Does that make sense? So you have, and think these are in pairs, all right? So this pair goes to one, this pair goes to one, that pair goes to one. So many going to one. Question number 47. H, and this is functions, right? H of x is equal to 3x minus 2 over 5, the value of h of minus 6. All this is saying is that wherever you have x in the expression, you're going to put minus 6. So I'm going to have 3 times minus 6 minus 2 over 5. We know how the laws work. We'll have to do brackets first. 3 times negative 6 is negative 18 minus 2 over 5. Now negative 18 minus 2 is what? Or 18 or 2 more, negative 20 over 5, which is negative 4. Alright, that's how we do question 47. Question 48. By looking at this, we know it's a quadratic. Alright, so it says refers to the following 48 and 49. So we're going to be answering these two questions using this graph. Alright, so it says the maximum point of y is equal to 4x minus x squared is maximum means the highest point on the graph, right? And we can see it has a maximum turning point right here. This is the highest point on this graph. So the maximum point right here, and remember how we quote this now, we take the x value and then the y value, so that's 2, 4. Then it says the values of x at the point where it intersects the line y equals 0 are. We know what do we mean by the line y equals 0. The line y equals 0 is basically this horizontal line that crosses 0 on the y-axis, which is another way of saying the x-axis. So bear in mind that the line y equals 0 refers to the x-axis. X equals 0 refers to the y-axis. So all this question is asking you, where does this graph cut the x-axis? That's all it's asking you. Where does it cut the x-axis? And let me go down so you can see this. So let's look. It touches the x-axis at 0. That's 1 point. Also touches the x-axis at 4. So those 2 points would be x equals 0 and x equal 4. Option A as in apple. Alright, let me take this out a bit. Alright, question number 50. Which of the following equation represents a straight line? Now, we know that straight line, we're typically looking for y equal mx plus c. We can rearrange it, but we're looking for mx plus c, where m and c are numbers. Alright, so clearly, it can't be a, because that is saying xy. We can't be b, because we're looking at x squared. That's out. C, y equal 3 plus 2x. If we were to just bring over the 3, it will have the perfect format. So I know it's C. Question number 51. Which of the following sets is represented by the function f is such that x it maps onto x squared plus 3, where x is equal to 0, 1, 2, 3. Now, our x is a member of the set 0, 1, 2, 3. Let's try to understand what's going on here. What we're taking is that we're taking these values of x, we're going to pop them into the function x squared plus 3. So we're going to square each of these numbers and add 3. Square means you multiply the number by itself. So 0 times 0, and that is what is going to give you the y values, of course. So we're focusing on the y values, which comes second. So 0 plus 0 is 0. 0 square, sorry. 0 times 0 is 0 plus 3. That's going to give me 3. Alright, everything has 3, so that's perfect. What about when I use 1? So if I go 1 square plus 3, 1 square is 1 times 1 plus 3, which is 4. So I know that 1 is going to go with 4. So we can kill option C, and we can kill option 1. Moving on to 2. So we're going to have 2 squared plus 3. 2 squared is 2 times 2. 4 plus 3, 7. Now, does both B and D have 7? 2 with 7? No. B has 2 with 5, so that's dead, which means that D is the answer. What's the point of this question here now? Remember, you don't always have to work out everything. You just need to work until you get to the correct answer. Alright, question 52. A line L is parallel to this line. What do we know about parallel lines? They have the same gradient. What's the gradient of line L? Now, can I just look at this and determine the gradient? No, I need to have it in the format y equal mx plus c, where I know that m is my gradient and c is my y-intercept. So let's start about rearranging this. We just need to carry over everything apart from the y. Now how do I bring these over? We have 2x minus 5y minus 8 equal to 0. Clearly when I bring these things over, they're going to become negative because we're going to have to subtract them. Bringing them over is a shortcut of saying we're subtracting them from both sides, or we're adding them both to both sides. So we're going to have the minus 5y still over here. 2x is positive. It's going to over as a negative 2x. 8 is negative, which comes over as a positive 8. Then we're going to have to divide by minus 5. So we can divide each term by minus 5 or collectively. The same thing. Now we're only focusing on the gradient part. Now negative over negative is a positive. So we have 2/5 x. The gradient is 2/5. Alright? So you pay attention to your signs. That's also key as well. Question number 53. Alright, so we're looking at circle theorem now. It says in item 53 refers to the following diagram of a circle. If O is the center of the circle, then Y is. Now what do we know about the angles formed at the center of the circle? It's twice the angle formed at the circumference by the same arc, okay? Or by the same chord rather. So Y here would be twice the angle here, which is 50. Twice 50 is 100. Now let's say we never know what to do. Technically, not recommended, but if you're out of options and you don't know what to do, most of the times the circles are drawn properly really. So you can just take what should I say now? Take your protractor, measure the angle. That's if you don't know. It's gonna be pretty close to the correct answer. You should definitely be getting the 100 there. Alright, trick you can use is it will say it's not drawn to scale, but when you draw a circle, the circle normally has to be drawn to scale. They might shift the center a bit, but you can still measure. It's going to be close enough to the answer. Alright, that doesn't say you need to know the circle theorem, because on paper 2 it's definitely not going to be drawn to scale and you have to give a reason on paper 2. Alright, item 54 refers to the following diagram. In the diagram, P, Q, and PS are parallel. So these are parallel lines, which is important. Whichever following best describes the relationship between X and Y. Now, think of this. If you ignore those two things, right? It's basically taking out the complication. X is here, Y is here. This is a letter Z. Now, what do we know about letter Z? The top part here is the same as the bottom part here. It's just like you flipped it over. So it means that these two angles must be equal. Alright? That helps to form the Z. They have to be equal, because we're just looking at a Z. The top and the bottom are the same on the Z. Alright, let's take it over to 55. Now, we're looking at what? Transformation geometry here. And I probably should get this moved over somewhere here. Alright, let's keep it there. So it refers to the following diagram, which shows rectangle WXYZ. Alright, we can see that there. And its image W prime, X prime, Y prime, Z prime, which we can see over here. And W double prime, X double prime, Y double prime of an angle goes a composite transformation. But without even looking at the question, guys, if you look at this, clearly you see that this is reflected in the y-axis, right? Because both of them are equidistant from the y-axis, and you have that lateral inversion, eh? So they're same distance from the y-axis with that lateral inversion, which is what happens when you look exactly into a mirror. Now it moves from being the X prime, W prime to being something smaller. So that's an enlargement, but of course by a fractional amount. So I guess the question is probably even going to ask you something about that. Which sequence best describes the transformation which maps WXYZ onto image rectangle W double prime, X double prime, Y double prime? You already know the answer because you saw it when you look at the diagram. You saw the reflection and then you saw the enlargement. And if you look at this, how do I know what the enlargement here is? Take any respective sides, like take w prime z prime and take w prime z w prime. This is just half of that. So it's like we halved this triangle then, or this rectangle, we halved it. So that's how we got down to this. Or we have any corresponding length. Because I don't want to, we'll say we halve it and you're thinking the area. No, we're talking about the lengths of the sides. So let's go down and see if we can find an answer that reflects, because we already knew what the question is going to ask. So we saw the reflection first in the y-axis. So it says a reflection in the y-axis followed by an enlargement centered at origin with a scale factor of a half. Has to be option B. A, translation, we're ignoring that. C, rotation, completely out, we're not even into that. Enlargement at the origin with scale factor of a half followed by rotation, spoil it. We're totally out of that. So it must be option B as in boy, which in a sense you figured this out before you even read what the question had said, because you're seeing the process taking place. All right, 56. In each of the following diagrams, A prime is the image of A, which of the following shows a reflection in the x-axis. All right, so you need to find the x-axis, right? The x-axis is the horizontal axis. So if it reflects, they're going to be on opposite sides of that x-axis. Good. D, you don't have to think about it. Once it's reflected in the x-axis, it must be on opposite sides of the x-axis. B would be a reflection in the y-axis. Y is the mirror. In this case, X is the mirror. Divides them in two, or gives you that symmetry. So even if you fold the paper, it overlaps on the x-axis. Alright, going for question 57. It says, in the triangle ABC, angle A is equal, and I like to have diagrams when I'm doing this thing. A, B, C. Angle A is equal to X, nice. B is equal to 2X, nice. C. Now we all know that angles in a triangle add up to what? 180. So if we have X and we have 2X, the total there is 3X. Remember that all these angles need to add up to 180. So if I know what these two angles are to get my final angle, I just need to take 180 and subtract these angles here. These are the two angles. That's a general rule. If you have two angles, the next angle is 180 minus what the sum of those two are. Alright, item 58 refers to the following diagram, which shows an angle of depression of a point X from Z. As we can see here, the angle of depression is 35 degrees. The angle of depression at the point X from Z is 35. If X is 12 meters away from Y, the height YZ is. Alright, let's start with some things that we know. Now remember that we were looking at that Z angle there. Also what we call alternate angles. So we know that the Z, once it forms a Z, the top part of the Z, which is here, and the bottom part of the Z have the same angle, 35 degrees. So now we can just focus on this right angle triangle here. We don't have to get too complicated with it. Now the only thing I need to ask myself, so ka toa, what side do I know with respect to the angle, and what side do I need to find with respect to the angle? The angle is right here, 35 degrees. The side that I know here, so this is a hypotenuse, HYP. Now clearly, there's the thing is asking you for the height, which is YZ or ZY, which is over here, opposite to the angle, adjacent. Now, the side I know is the adjacent side. The side I want to find is the opposite side. There's no situation in which I need cos, which is adjacent, and hypotenuse. A and B totally out. Sine also requires the hypotenuse, which I don't know. I don't need that either. The only thing I need is the adjacent and the opposite, which takes me to tan. Question 59. We're almost there, guys. Alright, refers to the following diagram of a right angle triangle ABC. In the right angle triangle above, which trigonometrical ratio is equivalent to 4/8. Alright, so let's look at x. X is here. If you're looking at this angle, this side with respect to x, this is opposite. And this is hypotenuse. Once again, so ka tua. Alright, so opposite and hypotenuse, we know is what? Sine, right here, opposite hypotenuse. And that would be sine x. Now, do we have sine x here? Yeah, we're good to go. The answer is A as in apple. Now, could it be with respect to y? Of course. If we're looking at y here, adjacent, which means next to, is 4. 80 is the hypotenuse. So in this case, it will be cos, because we're going adjacent hypotenuse. But we don't have cos y, so nah. Question number 60. Under the translation, once again it's transformational geometry, the image of -5,3 is. So with translation, we simply just add it to get the image. So we add this to the object, which is this, to get the image. So we have -2, 3 plus -5, 3, add them, just like how we do with vectors. -2 plus -5, O2, bar 5, you owe 7, have 3, which is positive, add 3 more, also positive, you get 6. This is it in what we call vector form. And then we go back to our coordinate form, which is -7, 6. So your answer there is C, as in Charlie. And that takes us to the end of the 2023 January multiple choice past paper.